Hey guys and girls, today is all about trapezoids and kites. So we're going to start with some trapezoids, so we need some definitions. So on your worksheet, fill in for those definitions there at the top. We have our basic definition of a trapezoid, and then we have a special trapezoid called an isosceles trapezoid. Now, by definition, a quadrilateral with exactly one pair of parallel sides is our trapezoid. So typically those parallel sides are at the top and the bottom, but you could turn your trapezoid to where they might be on the left and right. But the parts that are parallel are called your bases. So this is a base and this is a base. The other two parts are called the legs. But a trapezoid can be written in several different ways as long as two sides are parallel, two opposite sides are parallel. Now, an isosceles trapezoid is special. So an isosceles trapezoid has congruent legs. So these two parts are congruent. They still have those parallel bases. And the base angles are also congruent. So those are the ones that touch the base. So that means these two at the bottom would be the same, and these two at the top would be the same. If you drew in your diagonals, they would also be congruent. So your diagonals connect from corner to corner. So if we wanted to name this trapezoid, we'll be real creative. We're naming trap. We would say that TA is congruent to RP or PR. Those two segments would be the same length if it's an isosceles trapezoid. So now that you know those kind of pieces, then all kinds of other things kind of play in that we have. So isosceles trapezoids are just really special. If you notice the two legs are equal, then the base angles are equal, and the diagonals are equal. So lots of stuff happened with that. All right, let's find the measures of some angles. Now, these two are trapezoids, but they are also what kind of trapezoids? Isosceles, because we see that the two non-parallel sides are also equal to each other. So let's find all of these angle measurements. So if this angle here at C is 65, what other angle is also 65? F is also 65. Those two are equal to each other. Does it look like, and those two are acute angles, right? Does it look like the two angles at the top are also acute? No, they are obtuse angles. How do you think the bottom angles are related to the top angles? They're supplementary because these are parallel lines. This is a transversal. So E and F are same side interior angles, which are supplementary. That's right, because we have those parallel lines, all those angles from Math 2 pop back up, so same side supplementary. So what would we need to add to 65 to get a supplementary one angle? 115. So E is 115 and D is 115. So don't forget, same side supplementary. Same side. Good job. All right, let's look at our next shape. So we know angle R is 106. So what other angle is 106? S. Very good. This one is turned sideways, but it still works out the same way. It's the ones along the parallel that are going to be the same. And then how would we find P and Q? So that would be 74. Oops, sorry. I started right 5. My bad. 74 degrees for P and Q. So finding angles is pretty simple, right? Okay. So let's look about the median of a trapezoid. So yours is blank. So write down these 3 points, 3 bullet points about the median. Carter. Write them down. So the median of the trapezoid, if we go through that first bullet point, it joins the midpoint of the 2 legs. So we know this is a trapezoid. We put little arrows right there. Those 2 lines are parallel. The median is where? In the middle, right? Median, middle, midpoint, those all kind of go together. So this right here is our median, and that median joins the midpoints of the 2 legs. So middle, midpoint. So it joins the middle of this side and then the middle of this side. So the legs do not have to be congruent for a median. So it's not an isosceles trapezoid. This works for any trapezoid. So the median will hit the middle of both legs. Okay. Now, a second fact is that median is parallel to the bases. So now instead of 2 parallel lines, we have 3 parallel lines. Also, the length of the median is 1/2 B1 plus B2, where B1 and B2 are your 2 bases. So you can find the length of it using that formula. So let's do some examples. All right, find the value of x given the median is drawn in the trapezoids below. So remember that equation. The median equals 1/2 base 1 plus base 2. That's your formula. Just plug in what you know. So what's the median? Good. X plus 2 equals 1/2. Now, we need our 2 bases, which are, so 4x minus 10 plus 8. It doesn't matter really what order you put the 2 bases in because you're adding, and addition is commutative, which means you can switch the order. So, what should we do first to solve? Do what? You could times both sides by 2. That would get rid of the 1/2. You got another way? Yep, you could combine like terms in the parentheses. That's how I would start. I usually start with parentheses first, but if you times by 2, that's okay. What's negative 10 plus 8? Negative 2. So if you wanted to times by 2, you're going to have to times everything on the left side by 2. But if you go ahead and add like terms, you notice everything in parentheses is an even number. So can you take half of even numbers pretty easily? Yes. So it's whichever way you want to do it, you will end up getting the same answer. So I'm just going to distribute the 1/2 and have x plus 2 equals 2x minus 1. Now, if you do it the other way, you're going to end up with 2x plus 4 equals 4x minus 2. So you have to times everything by 2 over here. But again, once you solve, you should get the exact same answer. Okay, I'm going to solve this one over here, so I'm going to minus my x over, and then add my 1, and x equals 3. Now, it didn't ask me to plug it back in or anything. We're just solving for x, but be careful on tonight's homework. It may ask you to plug it back in. All right, let's do our next one here. It's the same kind of picture, just put the right things in the right spot. First, start with a median. What's my median? Good, and that's going to equal 1/2 base plus base. So in my parentheses, I'm going to have, that was good unison there. Sounded like the two twins from The Shining. Just kidding. All right, 2x plus 11 equals 1/2. Combined up those like terms. I'm going to put my 8x first. So we got 10 minus 12, which is -2. I'm going to go ahead and times by 2 just to show a different way of doing it. So let's times both sides by 2. You get 4x plus 22 equals 8x minus 2. So make sure when you times by 2, you times everything on the left side by 2, and then just drop the parentheses on the right. And I would minus my 4x. And then add the 2. Divide by 4, you get 6. Dun, dun, dun. So it's just doing some of that basic algebra. Just make sure that you follow those steps of solving and you should be good. All right, flip over to the back side for the next one. Lots of angles there. All right, the key thing is making sure that we know how to find our angles and what those angle measurements are. So we have here a trapezoid. We have a median in the middle because it cuts those sides in half. And if we have that, then we know that we have 3 sets of parallel lines. And if you have parallel lines, you have things like we had last week, which were 4 types of angles. We have alternate interior angles, alternate exterior angles, same side supplementary, same side interior angles. And the last one starts with a C, corresponding. There we go. Those are going to play into what we find here for our different angle measurements. So notice it says RTP is 85. T is that middle letter, RTP. So this angle right here is 85. Now, these are not isosceles. So the angle at T does not equal the angle at P, right? Do they even look the same? No, they're not the same. But because these lines are parallel, we could put some corresponding angles together. So if this angle at T is 85, corresponding would be the upper one at M. That's right. So this would be 85. Now, we could also find the angle below M. How is the angles at M related? They should be what? That's right. They should be supplementary. They should add up to 180 because right there at M is a straight line. So if this is 85, then this one is 95. And again, because of corresponding angles, this bottom angle at M should equal the bottom angle at R, or the only angle at R, which would be 95. Also, M and R are same side interior if you look at just that upper trapezoid. So when it's asking for RMN, if I were to trace that out, RMN is how much? 85. Then MRA. So MRA is that upper angle at R, 95. Very good. And then angle TMN. TMN, yep, you're right on saying 95. So 85, 95, 95. So if it's not isosceles, but you have the medians, the ones over here on the left side should be same side interior, which are supplementary, or corresponding, which are congruent. All right, one last thing about trapezoids is we need to know how to find the area of a trapezoid. And that formula is similar to the median, but we throw a h in there. So it's 1/2 h B1 plus B2. So write in that formula because it is not given to you on your paper. So 1/2 h parentheses B1 plus B2. Now let's find the area of a couple of trapezoids using that formula. Now h has to be this vertical distance here from one base to the other. It's like the altitude of a triangle, right? So that's exactly what it is for this. So when I look at this first problem, I have 1/2. What's the height of my trapezoid? 6, good. So 1/2 times 6. And then in parentheses, base 1 plus base 2. Good. Now, you can type all that in your calculator, or you can use some mental math skills. What's 1/2 of 6? 3. And then we're going to times that by 4 plus 10, which is 14. So what's 3 times 14? 42. And then don't forget this is area, so put meters squared. Of course we need units. Units are very important. All right, let's do our next one. So we have 1/2. What's the height of this trapezoid? 18. What are my two bases? 15 and 27. And then I'm going to use my handy dandy calculator because those numbers are quite large. I don't know if I trust you in your answers. $15 plus 27 is 42. Let's times that by 1/2 of 18 or by 9 and we get 378 inches squared. All right, this last picture is not on your paper. I think you can draw it up above those other two shapes that you had. So draw this trapezoid real quickly for me and let's figure out the area of that trapezoid. Sorry, I did not draw this one on there. This was an addition problem that I had. Okay, first off, we know our two bases, right? Their two bases are 10 and 14. We are missing the what? The height. So this is our height here, which is h. And we need to find it because if we want to set up our formula, we would just have this, missing that height. How are we going to find the height? It's not 4. If you were to look at a triangle, right, is this distance the same as this distance in a triangle? Because that's pretty much what we have here is a little triangle on the end. So this slanted length is not the height. We got to do Pythagorean theorem to figure out that height. But in order to do that, we still need this distance. Yes, you have to divide it by 2 because we would have to put another height over here. This 10 is just this distance. 10 is here. What does that mean these two are? 2 and 2. So you have to do 14 minus 10 divided by 2 to give us that measurement there. Yeah, the whole thing's 14. So you split it up into a rectangle and then 2 triangles. So now when I go through and do like my Pythagorean theorem, I have 2 here, 4 here, and h here. So remember, it's going to be h squared plus 2 squared equals 4 squared. 4 is the hypotenuse. So 2 squared is 4, and 4 squared is, so h squared is 12. So h would be, very good, 2 square root 3. You're right, because what multiplies to be 12? 4. 4 and 3. And what's the square root of 4? 2, and the 3 stays under. So if you need to make your little factor tree, this would be 4 and 3. So the 2 comes out, the 3 stays under. So inside my area formula, I'm going to put 2 square root 3. Now let's figure out how to make this an exact number, and then we're also figure out how to round it using our calculator. So first, multiply or add what's in our parentheses. 10 and 14 make 24. And then if you were to multiply these two numbers together, you're going to multiply the outside numbers together and the numbers inside the root together. So what's 1/2 times 2? 1. So really this is just square root of 3. So my answer is just 24 times the square root of 3. So when you multiply things that have a square root in them, you just multiply the numbers outside together. 1/2 of 2 is just 1, or those two cancel out. So I'm just left with the square root of 3, and I'm timesing that by 24, so I'll put that in front. Now, if you wanted to, you could also type that in your calculator to figure out what it would be as a decimal. I may ask you for exact numbers, but if you wrote it as a decimal, I'd still give you some partial credit. So this is about 41.57. So we've talked about how to find angles in a trapezoid, how to find measurements, how to find area. So let's talk about now some kites. So there's lots of definitions for a kite, so write this down by that picture there at the top. And the bottom 2 problems are just finding some angle measurements, so they will go pretty quick. But write down all that information. They were sausage balls. My friend gave them to me like a month ago, and I forgot that I didn't finish them. They've just been hanging out in my fridge. Because I ate half of them. She gave me like 7, so I ate like 6 or 7. So I ate like half of them. And then I forgot the next day to eat the rest for like a month. Yeah. Dun, dun, dun. We always have homework. It's no surprise. What am I going to be? Well, all the teachers are, not all of them, but a lot of us have a theme. So you're just going to have to be surprised. Yeah, last year we were rock stars, right? No, no. But this year it's very obvious. Oh, that would have been fun. We did not do that theme. Yeah, we didn't do that theme though. We decided something else. All right. Anyway, let's finish up this last part. So a kite is a quadrilateral with two pairs of consecutive. Now consecutive means kind of touching. So two pairs of consecutive congruent sides, but opposite sides are not congruent. So opposite in a kite would be AD and BC. They're the two sides that are across from each other that don't touch. So those are not equal anymore. In a kite, we have the two consecutive sides at the top are congruent and the two consecutive sides at the bottom are congruent. So I purposely laid this one on its side so that way we could see it. Now, a couple other facts is the diagonals are perpendicular, so that's similar to our square and our rhombus, that when the diagonals connect, they're all perpendicular. So we end up making four right triangles, right? Since our diagonals are perpendicular, we make four right triangles. And knowing one of the angles might help us to find the other two angles. Now, what's also true is exactly one pair of opposite angles are congruent. So what that means in this case is angle B is congruent to angle D. Those are the two that are congruent to each other. Because if you look at this kite, does it look like the angle at C is equal to the angle at A? No. But the angle at B and D are equal. Also, kites have a line of symmetry. So what does that mean? You can fold it in half. So if I was trying to, let's say, make a kite, I could take a piece of paper and fold it in half and then cut out a kite. And when I opened it, or half of it, when I opened it back up, it'd be the same, right? So that's key to remember, that it has a line of symmetry. In this case, our line of symmetry is AC. So if you can pick out your line of symmetry, then you can tell me everything else about that kite. Exactly. So other things that happen is B and the center and D and the center, those two would be equal to each other. So that one diagonal gets bisected. Do both of them get bisected? No. As we can tell, this one here, it's not the same. But it also means that this angle at B and this angle at D are equal. And the bottom angles at B and D are equal to each other. And also means the angles at A, right? They're bisected. So this angle, I'm going to mark it with 3, is equal to this angle. Because that line of symmetry, I could fold it in half, make a pancake. Which also means the angle at C is equal to the angle at C. So you can draw 4 little lines in there. So it kind of gets confusing when you start to draw all those angles, but if you remember the line of symmetry, that's going to help you find everything about this kite. So let's look at our 2 examples that we have here. We want to find the different angle measurements, and honestly, we just need one angle to find all the angles. All right, So here we go. What do you know about angle 1? It's 90 degrees because those diagonals are perpendicular. So all of those in there are 90 degrees. Done. Next one we should easily find is angle 2. 46 because that's right. And this is a what? Line of symmetry. So if I folded that in half, bam, pancake, 40, whatever, 6. All right, angle 3. Why 44? You're exactly right. That's right. Remember, it makes a right triangle. So if this angle's 90, this angle's 46, that angle has to be 44. So if you wanted to write them in, that way you can see it in the picture. You can, draw a triangle to the side. There's a triangle. So those 3 angles should add up to be 180. Okay. Now, in our next picture, it's a kite, but we don't have the line of symmetry. So if you put a line of symmetry in, would it go horizontal or vertical? Vertical. So what does that mean about angles 1 and 2? They're the same. They should be equal to each other. So whatever you put for 1, you put for 2. Now, this one is not broken up into our 4 triangles, but it is broken up into this big quadrilateral shape. Now, what do you know about all the angles in a quadrilateral? They equal 360. So we could do 360 and subtract the 2 angles that we know. We can get that number, and once we get that number, we would do what with it? Divide it by 2, and that will give us 100.5. Sounds good. So those 2 angles are 105 degrees, 100.5 degrees. All right, your homework is a worksheet that I believe is on Canvas, but also what I want to tell you is you guys have a little kite project. Dun, dun, dun. Now, it is not due until Monday, so you have plenty of time to do it. So let me find it, though. Bum, bum, bum. I called it something. What did I call it? Making a kite. It's going to show up all kinds of crazy, but it's online so that way you can see it. It's called Let's Go Fly a Kite, people. Have you ever heard that song before? Of course I will. Let's go fly a kite. All right, anyway, here's the things that you need. You need a ruler, a protractor, construction paper. I guess I should have put scissors and something to write with as well. All of that stuff is laying there on the back table for you, so you can work on that at any time. You will have some time tomorrow because tomorrow is our review day, and once you finish tonight's homework, you still got 40 minutes, so you should have some time to work on it as well. First off, what you're going to do is make a kite out of colored paper or construction paper. If you do want to make it on just a white sheet of computer paper, then that is fine too. So it may look something like this. Here's a kite. Make sure that it follows all of the properties and definitions. So you are not making a rhombus. Rhombus and kites sometimes look similar, but we're not making a rhombus. We're making a kite. Okay, on the back of your kite, you're going to draw in your diagonals. So on the front, you can design it however you want to, but on the back, you are going to draw in your diagonals, which connect the top and bottom, left and right, and then you're going to measure with a ruler all 4 sides and all 4 parts of your diagonal. Okay, so you're going to have 8 measurements that you're going to make with a ruler. And what's the easiest way to measure? In using what? Centimeters. That's right. Then you are going to measure all of your angles. There are actually 12 angles to measure. There's 2 at the top, 2 at the bottom, 2 at the left, 2 at the right. But then also measure the 4 in the middle where the diagonals meet. They should be. Make sure they are. So you're right. So you've got 12 angles to measure, 8 lengths to measure, and then once you measure all that, decorate the front. Some people ask, could you put a tail on your kite? And you can, but you have to attach the tail to the front because I have to measure your angles on the back. Okay, so if you want to put a tail on the kite, you just attach it to the front, or you can add that tail after I grade it and give it back to you. And then we're going to staple our kites around the classroom so everyone can see them. Okay, now, point-wise, it's 4 points for each measurement that you have. It is 10 points for following the theorems and definitions, and it's 10 points for the design. So if you don't design the front at all, you automatically get a 90. And we want hundreds. Okay, this kite, again, is not due until Monday, so your little kite project here due on Monday. Again, you'll have some time today and tomorrow to do it. It counts as a quiz grade. You are correct. Yes, I should have pulled that up. So it counts as a quiz grade. Should be an easy quiz. All right. Homework's on Canvas. Jump to it and do it. Make sure that you label all of the things that you have because the first several problems. Actually, I'm not going to put it on Canvas. I'm going to print this worksheet because I just realized how long it was. So put your stuff away. I will print the worksheet. Sorry, video people. I don't know what I'm doing. There we go.